Welcome to the Hydrogen Safety Set webinar. My name is Chris Worth and I am the organizer for this meeting. We'll begin shortly, but first I have a few housekeeping items to tell you about. Today's webinar is being recorded and the recording along with the slides will be posted to our website in about 10 days. We will send out an email to attendees once those are posted to the site. All attendees will be on mute throughout the webinar, so please submit your questions via the questions box that you should see on your webinar panel. We will cover those questions during the Q&A at the end of the presentation. Since we have multiple speakers today, please indicate who your question is for when submitting your questions. With that, I would like to introduce our DOE host, Will James, joining us from Washington, D.C. Will leads the Safety, Codes, and Standards program in the Fuel Cell Technologies Office. Good afternoon, Will.
Thanks, Chris. As Chris already mentioned, my name is Will James, and on behalf of the Fuel Cell Technologies Office, I would like to welcome you to today's webinar. I will be moderating today's webinar and would just like to say a few words before we proceed. This webinar is designed to be the first introduction to the National Hydrogen and Fuel Cell Emergency Response Training Resource that was announced in February by the Fuel Cell Technologies Office, along with its potential uses and future enhancements. We are pleased today to have two speakers, Nick Barillo from the Pacific Northwest National Laboratory and Jennifer Hamilton from the California Fuel Cell Partnership. Nick is the Hydrogen Safety Program Manager at Pacific Northwest National Laboratory and a licensed fire protection engineer with more than 30 years of experience. Nick has served on the NFPA-2 Hydrogen Technologies Code Committee since its inception in 2006 and was instrumental in organizing the first 8 chapters of the initial release of the code in 2011, and he continues to be an active member. In 2007, Nick joined the Hydrogen Safety Panel and has served as Program Manager for Hydrogen Safety supporting the DOE's Fuel Cell Technologies Office since 2012. As Program Manager, Nick directs activities for the Hydrogen Safety Panel, safety knowledge dissemination, and first responder training tasks, which include the development of the Hydrogen Tools portal. Our second speaker will be Jennifer Hamilton from the California Fuel Cell Partnership. She is the Safety and Education Specialist and has led the outreach and education to first responders and permitting officials at the partnership since 2006. She has reached thousands in the California community where hydrogen fuel cell vehicles and stations exist and will be coming soon. In addition to working with PNNL on the National Emergency Responder activities, she has a working relationship with the California Office of the State Fire Marshal, the U.S. Department of Energy, the National Fire Academy, and the NFPA for implementing first responder education. In parallel, Jennifer also actively participates in various safety codes and standards groups, including SAE International, the CSA Group, and ISO on items related to vehicle and fueling station safety. As a reminder, please, as Chris mentioned, please don't forget to submit your questions in the box over to the right. And so now I thank you, and we'll now turn it over to Nick.
Thanks, Chris and Will, and welcome everyone to this webinar on hydrogen and fuel cell first responder training resources. Next slide. So the national program that DOE has focused on first responder training is to support the successful implementation of hydrogen and fuel cell technologies by providing technically accurate information on hydrogen safety and emergency response information to first responders. This includes three primary parts of the training resources. The first is an online awareness level training, the second a classroom and hands-on operations level training with props, and the third is the recently announced national training resource. Many of these training resources were developed in collaboration with the California Fuel Cell Partnership, and we are currently also partnering with the National Fire Academy to identify ways for broader dissemination of the information. The key here is that a properly trained first responder community is critical to the successful introduction of hydrogen fuel cell applications and their transformation in how we use energy. Next slide. While cars are coming, hydrogen infrastructure remains the greatest challenge to commercialization of hydrogen fuel cell electric vehicles. To address this, in 2013, DOE, along with automakers and other key stakeholders, launched H2USA, a public-private partnership to address the key challenges of hydrogen infrastructure. H2USA currently has 35 participants, including the state of California, as well as developers, car companies, and hydrogen providers. Having properly trained first responders will address a key barrier, ensure a safe transition to fuel cell vehicles and hydrogen infrastructure, and pave the way for broader public acceptance. Next slide. The partnership contains 4 working groups. It's a locations roadmap working group, a market support and acceleration working group, a financing infrastructure working group, and the hydrogen fueling station working group. This project is in support of the activity of the market support and acceleration working group. Next slide. So this is a rather mature program, as you can see from the timeline provided on the screen. The initial activity started in 2002 with the California Fuel Cell Partnership developing an ER education program. In 2007, DOE released the online awareness level training, followed in 2009 by the operations level class and props being made available. The National Hydrogen and Fuel Cell Emergency Response Training Resource was announced last month, was actually made available on October 1st. We have plans for future enhancements, which we'll talk about later. Some of the accomplishments to date: the online training has seen over 31,000 visits. The P&L-based operations level training, which includes the props, has been attended by 1,000 firefighters. The California Fuel Cell Partnership training has reached over 7,000 first responders. Next slide, please. So let's take a look at the first part of this, which is the online training. As you can see, this is a slide taken from the actual online training. It covers 7 topical areas, excuse me, including basics, hydrogen vehicles, stationary facilities, emergency response, transportation and storage, hydrogen dispensing, and codes and standards. Next slide, please. So this slide is an example slide of some of the content that is in that online training. And as you can see down in the lower left, there's audio controls for listening into the narration, or if you want to read, it's the same text there as well. Okay, next slide. The operations level training consists of typically 2 parts, though it can be modified and made to whatever is needed for a particular venue. Classroom content, which covers things like fuel cell basics, vehicles, stationary applications, emergency response, and incident scenarios. Demonstration with hands-on prop is also been done. That's part of that 1,000 persons that have taken it, and that includes demonstration of the flame characteristics of hydrogen, as well as student participation in rescue activities. Next slide. This is out of our table content for our instructor's manual for that, just to give you a little better feel for what some of that content is. Also, a couple pictures at the right there provide some view of some of the classes in action. That's IR camera that's picking up the flames and showing the difference between the hydrogen flames and a propane flame. The lower right, so the actual vehicle prop you'll see up there is the silver prop. In the lower picture is the silver car is the prop, and the other cars are there for part of that hands-on exercise. Next slide. So all of the training that we've done over the years had led us to a place of realizing that we needed to provide materials to enable trainers to perform their own training. As things develop here, it's obvious that we're not going to be able to do all the training, and that's not really our central focus or goal. So the partnership and P&L got together with the intent of developing a consistent source of accurate information and current knowledge that's adaptable to the specific needs of the training organizations. So the goal here was to help put a set of information out into the hands of the trainers so that that they could have a consistent theme and a consistent messages being said, so that we don't get off into themes or messages that may not be accurate. It's also to enable that information to be as up to date as possible. So the course is set up with a template, if you will, and I'll show you a picture of that on the next slide, with various levels of how it can be applied. I would stress that that we really do need feedback from the users. It will help to make the program better in the future. So if you download that material and you look at it or use it and you have some feedback, we certainly welcome that, and it will help improve it for everyone. So highly encouraged. As you can see on the current slide, that the material is really came from all our learnings and all our materials that were presented before. So it's approved and vetted material. It's been updated. There's 3 levels like I talked about, but while we provide 3 levels, it's not meant to be prescriptive. You could take and use pieces of that 130 slide deck in whichever way you feel is appropriate for your audience. Next slide. So kind of we took an outline approach at really assembling the material and developing new material, and this kind of gives you a look at how we developed this outline with the various topics. Next slide. And I mentioned that we've broken it into 3 levels, what we would call an overview course, a short course, and a full course. So a lot of those topics that you saw on the previous slide, and you'll see on the next 2, are actual slides that came out and were developed, and we've kind of tried to give you a recommendation here with the check boxes on which ones would be appropriate for which type of course. It's not meant to be restricted, though, and you have the freedom to use it in any way you see fit. So next slide. So here we are breaking down the topics a little further. You can see how those topics, as they break down, and we bring slides. Those are actual slides from the slide deck, and show how some of the subtopics are covered and presented in information. Next slide. In addition, there's also practical exercises at the end to walk through with your group to discuss those. And at this point, I'll say before I move too much further that each slide is provided with notes on for the instructor to help them understand and apply and present that information. So we don't leave you hanging with just the information itself. We give you some guidelines and help for how to lead the instruction of that material as well. Okay, next slide. And I think at this point I'm going to turn it over to Jennifer, who will take you through the short course, and we'll talk a little more at the end when she's finished. Jennifer.
Thank you, Nick, and welcome everybody. So I'm going to go through an example of how the material could be used in the form of sort of the overview level, and so this will again be high level. I'm going to go through and sort of give some of the talking points and talk you through, and as opposed to giving the actual presentation. So next slide. This slide is really, I think, for the instructor to give some background on the program and why we're making this available. I wouldn't necessarily recommend, if the trainer feels the need to read it to the audience, but not necessary. Go ahead. Next slide. Okay, so this is just the title slide, and there we go. So, of course, we start with an introduction and background. Each section will have a sort of title slide like this, giving some outline of what the section will cover. Next slide. So we start with a high-level fuel cells overview. Some of the talking points for this slide, and as Nick said, they do come with notes. Are the overall message that fuel cells convert chemical fuels directly into electricity, and you can go into some of the diverse energy sources for the fuel, the different kinds of fuel cells, and then the diverse applications for fuel cells. So it gives some high-level background, some context, in terms of where this technology is being used. Next slide. A question that can come up often is why even do hydrogen? So this slide is meant to go over some of the reasons why the industry has looked at hydrogen for a transportation fuel. Some of the bullets there are that, to highlight it is a fuel, but it does have a good, it can be just as safe, if not safer than gasoline, and actually has a good safety record in industry for quite some time. And some of the other advantages, you could say, of using hydrogen. Next slide. Also, where hydrogen comes from. People may not be aware that it's actually produced in some pretty great quantities currently. And so this slide is meant to talk about the more common method of producing hydrogen from natural gas, and then the fact that moving towards the renewable source for both the energy and the source of hydrogen is, where we ultimately would like to see things going, and that's where the research, much of the research is headed, and the renewable pathway. Next slide. This is a nice list of current industrial uses for hydrogen. So again, just giving some context, hydrogen isn't new in the sense that it is used in industry. What might be fairly new concept for folks is the fact that it's being used as a transportation fuel, or for some of these other applications in personal use and portable power and stationary power. So, and again, highlight the safety record. It has a fairly good safety record in industry. There are, in the notes, a few resources for the trainers as well on production and hydrogen facts and things like that. So they can dig a little bit more into this if they'd like. One of the kind of, I think, main talking points on this is, and people may not realize, is hydrogen is used extensively in the gasoline business for refining fuel. So it just sort of, again, gives it a little bit of context. Next slide. And then we get into some of the properties of hydrogen and behavior. It is a little bit different in some areas than maybe some other fuels that folks are more used to dealing with. One of the main things is the fact that it's a cryogen. And so there's a few sub-bullets there pointing out that while we're using hydrogen, gaseous hydrogen, compressed for storage on the vehicles, it doesn't have a liquid phase in that when it's compressed. And it actually needs to be at the -423 Fahrenheit for it to be liquid. And the reason that that's different is things like propane or some more commonly used items, pressurizing it does cause it to liquefy. So it's just, I think, an important distinction to point out, a difference of hydrogen than some other fuels. And then another talking point is that last bullet, that a kilogram of hydrogen is approximately equal in energy to a gallon of gasoline. So if you were to burn a kilogram of hydrogen and burn a gallon of gas, you'd get about the same BTUs. Next slide. So going on further in some of the properties, looks a little academic, but there's some kind of higher level talking points here. Point out the buoyancy, the fact that hydrogen is 14 times lighter than air. Also, again, back to the kilogram thing, that it is metered, and we talk about it by weight, and it has more energy by weight than by volume than gasoline when comparing it to gasoline. And for emergency responders, this can be an important point because when you put this together with the fact that fuel cells are very efficient in how they use the fuel, there's a lot less energy that's needed on board the vehicles to get comparable range. So there's 4 to 6 gallons of gas equivalent in energy to get the range in the 250 to 350 plus mile range. Another talking point here is the fact that hydrogen is odorless, and there is, of course, or captain that's used to odorize natural gas, and gasoline has its own odor. So the reasons for that are the buoyancy and small molecular weight of hydrogen, but more importantly, the fact that an odorant can be detrimental to the fuel cell and its function. So there are other methods for detecting hydrogen that would be gotten into in more detail in a more detailed presentation. Next slide. I think it's important to recognize that, of course, hydrogen is flammable, and here's again a comparison of hydrogen to other fuels that, again, people are a little bit more used to dealing with. And there are both flammability and explosive limits listed here because for hydrogen they are actually these two sets of numbers. The important thing to point out is that the hydrogen gas sensors, for example, employed both in vehicles and at stations are going to be reacting and designed to ultimately shut systems down at levels below that lower flammability limit. So while we recognize that hydrogen does have a wide flammability range and there are safety systems to mitigate getting to those kinds of levels of hydrogen and air mixtures. The other thing, well, one of the other things to point out is the most easily ignited mixture in air is quite a bit higher than, again, more familiar fuels, and that while a pure hydrogen flame can be difficult to see with the naked eye, the radiant heat is lower because there's no carbon there. The internal flame temperature is still quite hot, so that's a comparison on the bottom there of the flame temperatures. Next slide. So then we get into some basics of fuel cells, just again pointing out that there are different types, and I believe that, yes, one of the talking points on the slide is that it is a PEM fuel cell that's used on board the vehicles. You can have different types of fuel cells for stationary applications or portable or things like that. But when talking about light-duty passenger vehicles and buses, it's a proton exchange membrane hydrogen fuel cell. Next slide. So this is a diagram that has been quite popular in California Fuel Cell Partnership publication of how it works. So it's a diagram of obviously how a fuel cell works. And we've given this out in our How It Works booklet thousands of times, I could say, at various outreach events. It's been very useful, and I think gives a good play-by-play of what's going on inside the fuel cell and how the vehicle is generating its electricity using hydrogen and oxygen. Next slide. So we want to move on to an overview of the kinds of vehicles that someone might see in their community. The fact that these are electric vehicles, only they're not plugged in like a battery electric, and they're a hybrid, only they're not fueled with gasoline or some other fuel, they're fueled with hydrogen. And like an electric vehicle, they're very quiet, and they're also zero emission. Of course, we have the bus on there because there are fuel cell buses as well. Next slide. And then to point out some of the vehicles that are being driven by your average everyday consumer. They've been in lease programs in different sizes and areas in California and a few places elsewhere in the U.S. And so this, again, gives a, if someone has seen one of these running around their neighborhood, they can put it into the context here. Next slide. And then, of course, it's always fun to show what may be coming down the pipe. So this is Honda's concept vehicle that they unveiled recently and have been using in some of their outreach. So it's just kind of fun to maybe look at the future a little bit. Next slide. Giving an example of a vehicle system layout and pointing out that, of course, there's going to be variations in how these components are laid out depending on the vehicle, but essentially a fuel cell electric vehicle will have the same components, much like a conventional gasoline vehicle has essentially the same components. And so then there's talking points to go through each of these components and a little bit on their function here. Of course, we have onboard storage, providing fuel to the fuel cell, which is generating the electricity. It's distributed through power electronics to an electric motor. There's also the high voltage battery, which captures the regenerative braking energy, and we point out that there's still a cooling system on board the vehicle as well. So again, these might be laid out differently. One thing personally I like to point out is that the fuel tanks are in the same general vicinity that you would expect to find a gasoline tank or other fuel tank on the vehicle, but perhaps the fuel cell stack or the electronics can be under the hood or along the floor, and that currently all the vehicles have front-wheel drive, so the electric motor will be in the front of the vehicle. Next slide. The high voltage system is essentially what they have been, what first responders may have been seeing already in other hybrid and electric vehicles. The orange is indicating high voltage, and that there are safety systems in the form of inertia switches, ground fault monitoring, and so forth that will detect if the system's compromised, and it's essentially designed to short itself out. And something else that maybe a talking point is that during normal operation, the high voltage and fuel systems are isolated on shutdown of the vehicle. Next slide. Moving on to the fuel storage and hydrogen delivery. This is an example of a couple of the tank setups. So an important point here is that while the vehicles all store hydrogen, it may be in a single tank, it may be multiple tanks, and it just depends on the vehicle. So there's two examples here of a Honda Clarity and a GM vehicle with different tank system setups. The bullets there, that the distribution lines are lower pressure. So the pressurized fuel, the high pressure is for the most part isolated to the compressed hydrogen storage cylinders, and the pressure in the lines is stepped down and regulated to take to the fuel cell stack. Also pointing out that there are thermally activated pressure relief devices in each tank, and there are associated vents that can vent independently off of each tank or may be directed to a common vent location. Next slide. And looking at the same sort of thing in a bus, clearly with a larger vehicle, there are more tanks. A commonality with, for example, CNG buses is that they do carry the fuel on the roof. And again, there's the thermally activated pressure relief devices and all the associated tubing and so forth, should the tanks have to vent in the case of fire. Next slide. So talking a little bit more about the fuel storage system, this is a nice photo of Type 3 35 versus 70 megapascal cylinders, and showing the difference in the liner thickness and the carbon fiber overwrap. One of the observations that's often made by first responders is that this type of tank is very similar. It's not, different size, but very similar to what is in their SCBA that they wear, their packs that they wear for their breathing apparatus, in the sense that they're carbon fiber also. Again, highlighting the TPRDs and the robustness of the tanks. Okay, next slide. So this slide goes a little bit more into the tanks themselves and the fact that they are designed to meet very specific standards, and they go through some fairly rigorous testing for certification. They do come with a lifetime and have a safety rating that goes beyond what their actual service pressure is. And this is just some of the pretty main and intense testing that these tanks go through by batch. Next slide. And finally, this is just, again, to highlight that the tests are part of the design qualification for new tanks, that the qualifying factor is that they vent the contents and don't rupture. So they put them through various insults and then have to maintain the integrity and vent through the TPRD and not rupture. And those are in accordance with the most recent vehicle tank standards. Okay, I think that might be the last. Oh no, we do have to do stationary. Whoops. Stationary facilities. So this is just to go a little bit over where we're getting this hydrogen fuel and the different kinds of stationary facilities, which can include, of course, the stationary fuel cells, bulk storage, and fueling stations where the vehicles would be getting their fuel. Next slide. Of course, first responders are very familiar with these NFPA placards, but just to highlight that this is what they'd want to look for either gaseous storage or liquid storage. Next slide. And then here's some examples of actual fueling stations, and in the notes it goes through where each station is located and what their hydrogen source is. So that can be anything from on-site manufacturing through steam methane reforming or an electrolyzer to delivery via gaseous tube trailer, liquid hydrogen, or pipeline. And I think that actually is the last of the overview. I'll turn it back over to
Jennifer.
Yep.
Yep, thank you. Good job. So I do want to talk a little bit about how to download it and that sort of thing. So the resource is available right now. The URL is provided on the slide. That URL is part of the Hydrogen Tools portal, and just take a minute here to give you some input on what that's doing. The Hydrogen Tools portal is slated to come online here very shortly. Its purpose is to bring together a wide variety of hydrogen safety resources and web-based content into a single location to help those designing, approving, using, or responding to incidents understand the safety aspects, maybe do more investigation. It'll have such resources as best practices, lessons learned, compatibility of materials, some codes and standards information as well. And that's just a start. We have hopes and plans to bring additional resources into the portal to make it much more valuable for the users. So that portal, you can download the information right now, but the portal itself will be online probably in the next few weeks. Okay, next slide. So this is giving you a little bit of look at the portal, and again, centralized location. We are actually tailoring the portal to focus in on user groups. There's 8 user groups we identified. Those include first responders, AHJs/code officials, project proponents, operations and maintenance folks, that sort of thing. A responsive design. So we currently have an iOS app, a Hydrogen Tools iOS app that is available and brings many tools together. The responsive design that will be done with this site will allow it to be used on any mobile device, whether it be a phone or a tablet, and that'll be across Android, iOS, etc. So that's beneficial as well. And probably one of the more important parts is the the information here is going to be credible and reliable safety information from a trustworthy source. And one last feature that I'd like to highlight is we're working to develop trusted communities. So what that means is that for first responders, there'll be a community set up for first responders that allows those first responders to ask questions, respond to questions, make comments, that sort of thing. One thing we've found over the last few years in talking with a variety of folks is that they'd really like to have a way of connecting with others that have been a part of activities or projects to understand their learnings and benefit from those learnings and reach out. And so this was really a direct result of feedback that we received from those that have had some experience with deployments and dealing with the issues. Okay, next slide. So planning for the future. We're not really going to stop here. This isn't, we're not kind of drawing a line in the sand. We're really looking at updating the information, keeping it current, adding new types of media and content to make it a richer learning experience, as well as bringing it to a broader audience. And so to that purpose, we're finalizing a plan that was done together with a variety of first responders, equipment providers, et cetera, to look at what the options were. It identified things like new smaller props and prop kits that can help address the tactile needs of the participants, developing new and updated videos and enhanced videos, providing new photographs. We recognize that's going to be an ongoing challenge, and we really need to keep it in the forefront. And a little bit further down is considering virtual reality tools for immersing students in real-world scenarios. There's actually some work going on internationally along that lines, and it's a pretty interesting concept, and hopefully we can find a way to bring it to you as well. So next slide. So just to reiterate a little bit of what our vision is, it's really bringing that consistent source of accurate and current information to allow a variety of training regimes to deploy that material in a way that would benefit them. It's also to encourage collaborations among the stakeholders to achieve purposeful results. So at the end of the day, the goal here is to remove those barriers, help take down the obstacles for helping deploy the hydrogen fuel cell technologies, and to bring this to bear on the commercial market, and make sure the communities are ready to receive it. So, okay, next slide. So I do want to acknowledge this was done in a collaborative effort with the partnership, and we appreciate all their work. It was also done with funding from the Fuel Cell Technologies Office of the Energy and Efficiency Renewable Section of the U.S. Department of Energy. In particular, the manager of the office, Sunita Satyapal, and Will James, Laura Hill, and Krishna Waj. And also the reviewers. We had, this shows a list of reviewers, and in the planning we've actually had more folks come on board. So all those that have been involved in helping us bring this to you, we appreciate all their help and encouragement. Last slide. So if you have certainly questions, we'll take some of those, but if in the future going out you want to send questions to us direct or talk with us about anything, we've provided some contact information, and we look forward to your questions and feedback. So thanks for listening in. We appreciate the time, and I'll turn it over to Will to facilitate the questions.
Thanks, Nick and Jennifer. Great presentation. Before we get into the Q&A part, I just wanted to remind everybody, I'm not sure if it was discussed at the beginning, there should be a question box over in the, when you logged in, that popped up over on the right-hand side of your screen. So for those of you that were looking to where exactly do you submit the questions, please submit them there, and we'll try to get through them. So we're going to go into the Q&A portion of the webinar. And so the first question was asked whether the material would be available in PDF or not. So we typically would post the presentation as well as the recording about 10 days, within about 10 working days from the date of the webinar. But then the next question, probably for Nick, is just to basically give an overall perspective from the fuel cell tank size or capacity on how they differentiate between light-duty vehicles and buses.
Will, you can feel free to jump in on this one a little bit. The vehicles are typically 10,000 psi tanks with a capacity of around 5 kilograms. I believe the buses go into a higher range of 10 to 15 kilograms, but Will, you're welcome to join in on that one.
Per tank or total? Nick, did you mean per tank or total?
Yes, I'm sorry, per tank. That's correct. No, I think actually the tanks, so it's 5 kilograms, correct me, Jennifer, it's 5 kilograms on the car, and that could be one or split between 2 tanks.
Yeah, the range in the vehicles is between about 4 on the lower side and up towards 6 right now on the higher side, with probably an average around 5 or so kilograms total storage in the system. And then buses, I don't know individual tank storage, but total storage is in right around the 40 or so kilogram range, 40 to 50 kilograms total storage at 35 megapascal or 5,000 psi.
So Jennifer, while you're, the next question is for you.
Okay.
And the question is, are hydrogen vehicles required to be identified in any specific way so first responders know that the vehicle is hydrogen powered?
The vehicles are required to be badged accordingly with, make and model like you would expect any other vehicle. And there currently is a document in progress with an SAE for first and second responders that goes further into some badging suggestions. And that has also, there is work to harmonize those badging suggestions with other SAE safety documents for hydrogen and fuel cell vehicles. So, an example is with the current vehicles, for example, the Honda Clarity FCX. So it has the letters FC, which would indicate fuel cell. The new Toyota Mirai FCV, so again, FC indicating fuel cell. And something important that I mention in speaking with first responders is if a vehicle is a fuel cell vehicle, it will have no other fuel than hydrogen. So while the vehicle may not necessarily indicate hydrogen on it, if it's a fuel cell vehicle, it will be hydrogen. There are also, as an example of a blue diamond, which follows some previous badging for CNG that might be used, but it's not, again, not a requirement. So look for this document coming from SAE. Well, it's for auto manufacturers, but from the perspective of a first and second responder and being able to manage vehicles in incidents that has suggestions for badging. So I hope that answered the question.
No, I think that does. I know you mentioned secondary responders. Is there any plan to possibly introduce any information into the training material related to secondary responders?
I
think, yeah, Nick, you want to talk about that?
Yeah, so that's kind of been an ongoing, on and off again topic, and certainly one that I don't think we're ready to definitively say in either direction on. It's been recognized that secondary responders really need information and can play an important role. So how that's handled in the future is still yet to be worked through. And if you have some suggestions on that, we certainly would welcome your feedback. And if you're a desire to see more of that type of information, please let us know, because that may help shape where we go with future content.
Great. This question talks about the hands-on and rescue course. Is that a residence course conducted somewhere, or is it a traveling type class that you could bring to a certain location? And that would be for Nick.
So that's a really great question. Sorry I didn't address it sooner. Yes, it's the classroom and hands-on course is a traveling course for the most part. We're located in Washington State, and we have a facility here where we also can arrange for that to be given. As a matter of fact, we're having some tentative plans to provide that training in the Northeast in probably in the spring of 2016. So the prop itself is part of a trailer assembly, and we take that trailer and we travel to a location and then provide the classroom training along with the use of the prop and demonstration. Some response, if that's so desired, that sort of thing as well. So yes, it can be taken to locations, and that would be subject to working out the details and resources and that sort of thing.
Great. The next question, I don't know if it would need to go to Nick or Jennifer, but the question is, has DOT crash tests been developed for the light-duty vehicles?
So Will, feel free to jump in here too, but to my knowledge, of course, the vehicles have to be crash tested, and that is per current FMVSS for hybrid and electric vehicles, and the GTR will ultimately be adopted by NHTSA to be the hydrogen FMVSS, and that is in process. So I don't know if you have any other updates on that timeline, Will.
Actually, I don't know if I have the timing of it, but I just know that they're in the process of reviewing the document to convert it to the hydrogen-specific FMVSS now.
Mm-hmm.
The next question is around coordination. Talks about whether there could be any coordination either with Clean City The next question for Nick is, how does a company become involved in the training aspect for the basically giving the training for the first responders.
I think the material.
Specifically, has there been any learning
Not specifically with CNG trainers, but that's not training along with other alternative vehicle training that's been provided. For example, from LA Fire Department, they did an alternative fuel vehicle training within their department, and presented all different sorts of alternative fuels, and our component was the hydrogen portion. So, and we're certainly, I think, open to that. And as more alternative fuel vehicles are on the road, it would be, in my opinion, great to be able to, incorporate all of those. Because there are, one nice thing is the ability to sort of compare across the board, and some of the more detailed slides in the program do that, the similarities of the different types of alternative fuel vehicles in their systems. So it's nice when there's sort of a bigger picture on that.
I know in the webinar today we only saw a small snapshot of the slides, the type of slides that are in the slide package. But are there any materials within the bigger slide package that covers hydrogen sensors or detectors or leak detection?
Not the technology necessarily, but it goes a little bit more into overall safety systems for vehicles and stations, and does talk about the fact that they are employed, but it doesn't discuss the specific technology.
Just a few more questions as we're starting to wrap up. One question continues to build on coordination. Is there any thoughts to, or is there any coordination with the Department of Transportation's training program?
So we haven't worked directly with DOT to develop or implement any materials. Could be an opportunity in the future, just something that up until now hasn't been a direct relationship. Jennifer, I'm not sure if the partnership is anything direct with DOT.
No, it does remind me that I was given a contact at DOT to potentially connect with on this, and that they do have some training they're developing or have developed. So I think that's a good reminder for a follow-up.
And then the next question is for Nick. As you see the hydrogen use grow, do you feel that there could be a specific responder training for fueling stations?
So, not I'll try and answer the question generally, and maybe more specifically, if it's directed towards first responders. I think that the material that's there right now probably does an adequate job of covering that topic. If it is for the station providers and getting those the station operators, perhaps some first training, maybe general hydrogen safety training, and response to an incident type training. Right now there's no plans to develop that kind of material. I think there certainly are bits and pieces in this package that could be pulled out, maybe put with some additional information that could be beneficial. But there's no plans. Again, if just as the statement was with secondary responders, if someone feels that's a big need, I'd suggest you make that need known. The other thing is that it really falls on the station, the developers and the builders and the operating agencies to ensure that that's in place. And a part of it really does become a little bit unique to each one of those type of organizations. Some like to do things a certain way, others like to do it a little differently. And so the point that having some information available could be a beneficial thing. But again, it's the resources to develop that, and is that more done at a broad national level, or is it more beneficial to do that at the local level? It's just something that hasn't been, I think, thoroughly evaluated at this point.
If I could, Will, I can offer a little bit more of a comment in that there was a time when the partnership was revamping their first responder program that the idea was to make a parallel program for fueling stations, and the ultimate outcome and consensus was that kind of what along the lines that Nick said. I mean, the bulk of it can be covered in the first responder portion, and I realize we only saw a very high-level edition of the materials today, but there actually is quite a bit more with regard to fueling stations and other stationary applications in the whole slide deck. And the consensus at that time was that a separate program was not deemed necessary. And another point is that the communities that are getting vehicles, most likely they're going to be getting a station as well. So in doing the first responder training, we of course cover both vehicles and stations and response suggestions to that.
Thanks, Jennifer. The last question is for Nick. As you see hydrogen refueling stations and vehicles deploy, both from the U.S. perspective and a global level, do you see a need that these training materials can be standardized or adopted internationally?
Yeah, that's a great question and well timed. Yeah, I think there's an opportunity to do that. While much of the information has pictures and some of the application and requirements U.S. centric, there certainly is an opportunity for more global international use. We have been contacted by some folks in another country to possibly convert the material over to another language, and have given some positive feedback to that. So they'll be proceeding as well. And so I think, yeah, there's a great opportunity there, and even some opportunity for potentially some international collaboration on what material might be in the template material might be beneficial as well.
Well, thanks, Nick. With that, we're going to wrap up the webinar. Once again, I want to thank Nick and Jennifer for presenting the material, and thanks everyone who participated. I'm going to turn it back over to Chris to wrap it up. Thank you.
Thanks, Will. All right, everyone, that concludes our webinar today. Again, I'd like to thank you for joining in, and remind you that the webinar and slides will be available online at our website, listed on the slide there, in about 10 days. If we didn't get to your questions today, we'll take a look at those and try and email some responses back out to you. So look for those in the coming days. All right, that's it. Have a great week, everybody. Goodbye.